Hey y'all, in this video we are going over question 2 from your test 1 study guide. So for this we are going to use this velocity time graph here. Again, my number one advice is to always check your type of graph. You tend to make less mistakes when you double check what type of graph you're working with. So for part A, you're looking for the acceleration of the object from 3 to 5 seconds. I actually had a typo on my answer key for this question, which was very silly of me, and I apologize. So for acceleration on a velocity time graph, you are using slope. Remember that if you're not sure whether you should use slope or area, if you have your list of the 3 graphs we learned in order that we learned them, and you want to figure out what you need to use slope or area, if you are going down the list, you're going to use slope. Oopsie. I'm running out of room on my writing space here. And then if you are going up the list, you're going to use area. All right, so we are on a velocity time graph and we want to find acceleration, so we're going down the list, so we're going to use slope to do that. So for here, we're starting at, for our rise, we're starting at 10 and going up to 20, and this is where my typo was. Our rise is going to be 10 meters per second, and our run is going to go from 3 over to 5 seconds. So that is going to be 2 seconds. So that is going to divide out and give us 5 meters per second, or that's typically written as meters per second squared. Okay. All right. Now for B, we're looking for how far the object goes from 3 to 5. So again, if you're not sure what to do, if you're using slope or area, if you've got your list, we're on a velocity time graph here as evidence of the label. And we want to go up to position of how far, we're going to use area. So now you are looking for everything between your x-axis down here and your line. That will make 2 sides of your shape here. So we're going to close this off and make our shape. We don't get a perfect rectangle or a perfect triangle out of this. We get a combo. So we are going to do both and add them together. So for this, we are going to do 1/2 times our height of our triangle is 10 because it goes 10 up to 20. And then over 2 seconds wide, and then we're going to add the area of the rectangle, which is 2 seconds wide times its height is 10 because it goes from 0 up to 10. So we get an answer of 10 for the first half and then 20 for the second. Add them together and you get an area of 30 meters. Right? All right, now for part C, we want to know how fast it's moving from 2 to 3. And this one actually on it kind of sometimes tricks people up because you want to try and use slope or area, but you're actually not going to do either of that. You have a velocity graph. This graph is plotting the velocity you're going, which is also the speed you're going. Velocity just includes which way it's going. So we're looking for how fast it's going at from 2 to 3 seconds. So all you got to do is look at your line and look at where it's located along the y-axis. And in this case, it's 10 meters per second is how fast it's going from 2 to 3 seconds. So it's not that bad really, right? Now for part D, we're looking for when the object is slowing down. So again, this is when it's important to think about what type of graph you're looking at and what is going to tell you it's slowing down, right? So before you even look at the graph, think, okay, what am I looking for to tell me I'm slowing down? And what you want to look for is a diagonal line that is approaching 0. So if it's above the x-axis, it's going towards it. If it's below it, it's going to go up towards it. So for this one, our x-axis is at the bottom here. This diagonal would show speeding up because it's starting at 0 and going up to 10. This one diagonal is going from 10 up to 20, so that's also speeding up. And then last from 5 to 6 seconds, we're starting at 20 and dropping to a speed of 10. So that would indicate slowing down, and that's what we want our answer to be, of 5 to 6 seconds. Okay? And lastly, part E, we're looking for the total displacement from 0 to 6 seconds. So this one is the most time-consuming part of this, and you want to find area. So when you have a velocity graph like we do here, we're in the middle of the list. We want position. We've actually already done part of this already for question B, and we want to find the area of the entire thing, right? So we've already found this yellow section to be 30 meters from part B. Now we want to find the rest of it. So we are going to divide up. We have this triangle in the beginning, and then we have this rectangle, and then lastly we have this triangle rectangle combo at the end. So just each part of that, you'll find the area and then add it all together. So for the first triangle, you have 1/2 times 2 seconds times a height of 10. and that is going to equal to 10 meters for this first triangle. Then for the next box, it's just a width of 1 second times the height of 10. So you really don't even have to work any math out with that. It's just 10 meters. And then lastly, we have this triangle box combo. So the box is actually the same size as the one we just did. So 10 meters there. And then the one above it is just going to be 1/2 times 1 second times a height of 10. So it's technically just half of the box below it of just 5 meters. So now you take and add up 10 plus 10 plus 30 plus 10. So plus 5, it would be just 65 total there. And so your answer for E is 65 meters. All right. So if you still have any questions and need help with any of these, please let me know.